Hey guys, welcome to a lesson for section 2.2, Rational Exponents. So last lesson we talked about properties of exponents and things like that, and when we did, we had a simple condition, right? Our basic definition, b to the n, b was any number, and n was a natural number, right? 0, 1, 2, 3, 4, and so forth. And we had a way even to deal with negative numbers where we had, so we could incorporate all of the integers. We had -3, -4, right? We used the rule if we had b to the -n, it's just 1 over b to the n. So we've been able to kind of encompass all of our exponents that are any integer, so positive, negative, whole numbers. But what if n is a rational number? So to remind you guys, a rational number is the ratio of two integers. So we usually write it as a over b, and yes, it's fractions. Now, don't get too scared, right? Many of us are not very comfortable with fractions. Calculators can handle them for you. You just gotta kind of take it slowly and go at your own pace. So, let's talk about what rational exponents do. So, what I want to think about real quick is I want to think about if I have x squared to the, we'll use a question mark, to the something, and I want this to equal x. Okay? Well, what we know is how can I simplify this expression? Okay, well, we know to simplify this that if I have something raised to a power raised to another power, I multiply those exponents. So this becomes x to the 2 times our question mark. And we want this to equal x. I mean, the bases are the same, so if these are equal, then that means the exponents have to also be the same. And what's our exponent on this side? Well, our exponent here is 1. Right? If there is no exponent, it means we have an exponent of 1. So what I can do here is I can create a separate equation where I get 2 times the question mark equals 1. And I just have to solve for the question mark, figure out what this thing needs to be. Use our standard rules, right? So since I was multiplying, the opposite of multiplication is division. So we divide by 2. Divide by size by 2, we get that the question mark is equal to 1/2. Okay? What's another way? So basically what I did here is I applied this exponent, this question mark exponent, which we found to be 1/2, and it got rid of the squared. What's another way I could take x squared and make it equal x? What could I do to this side to make that equal x? Give me a second to think. That's right, square roots. So if I take the square root of x squared, that equals x. So what that means is taking the square root of x squared is the same as x squared to the 1/2. That's interesting. And it's really cool. It actually gives us a rule, okay, or at least the starting basis for a rule. If we have some base raised to the 1/2 power, that's equal to the square root of that base. Now, similar to the way that if there is no exponent, it has an exponent of 1. When we have a square root, if there is no index or no number in front, it's a 2. But we can kind of go through an exactly similar process, and we can say, okay, if I have b to the 1/3, that means I need to take, that's the same as taking the cube root. So if we have it to the 1/2, it's the square root. If I have it to the 1/3, it's the cube root. The way we write that is simply like this. So we say that this is the index of the root. It's the third root of b. All right? So in a more general sense, we can get this nice idea that if I have b raised to the 1 over n power, that is simply the nth root of b. Now, what in the world does the nth root of b actually mean? What is that? Let's talk about it a little more. So let's first talk about the square root. If we say that the square root of a is equal to b, that means simply that a is equal to b times b. Similarly, if we say the cube root of a equals b, that means a is equal to b times b times b. So if we said the nth root of a equals b, that means b to the n is a. So what's cool about this is we can get some really simple kind of answers. So if we say, what's the cube root of 8? What number times itself 3 times gives us 8? 1 times itself 3 times is still just 1. What's 2? Well, 2 times 2 is 4. 4 times 2 is 8. So the cube root of 8 is 2. Now, we get some really interesting facts and interesting things happening when we have negatives. So one thing we didn't talk about last class, and one thing that we want to be really careful with, is how to handle something like this versus this. Now, we may see these things go, okay, I have negative 2 squared. One just has parentheses, one doesn't. But these are read differently, especially using your calculator. The way we interpret these is very different. We need to be very careful about how we're dealing with this. This, in our calculator and in mathematics, is interpreted as negative 2 times negative 2, which gives us 4. But the way this is interpreted is we have to think about the negative sign a little differently. We think of it as almost a multiplier of that 2, okay? And so an easy way to think of it is what this is really saying is it's really negative 1 times 2 squared, which is negative 1 times 2 times 2, which ends up with negative 4. And so you can see that the way we write these is giving us a different answer. Now, you may see this and think, oh, well, this is negative 2 squared. But what this is meaning mathematically, and the way our calculator interprets, which is the most important thing, okay, is it's saying, oh, this is the negative of 2 squared. Okay? Because we apply our exponents before we apply any multiplication or anything like that. So we need to be very careful what we're doing in our calculators. If you ever square something and it comes out negative, you did it wrong in your calculator. Okay? So why am I talking about this? Well, what if, because b could be any number, right? And that b to the n, it could be any number. We could say negative 3 to the 18th, negative 3 to the 5, negative 3 to the 2nd, negative 3 to the 4th, whatever. But when I talk about b to the 1 over n, we come into a couple situations, okay? And our couple situations are either that we can have that n is odd. There's 1, 3, 5, 7, and so forth. If n is odd, okay, then b to the 1 over n equals the nth root of b, no problem. But what if n is even? This actually gives us 2 possibilities. Okay? If n is even and b is less than 0, so b is a negative number, okay, this is undefined, okay? And let's think about this real quick. Let's do an example over here. What this is saying, so our b value, our base of our exponential is less than 0. So it's a negative number. Let's just go with negative 4. And our n is even, so let's just do the 1/2. Okay? Now, again, is it this case or this case? So let's make it very clear that we are dealing with this case here. We are taking the 1/2 power of negative 4. So by this rule that we kind of initially came up with, where it's just the nth root of b, this would be the square root of negative 4. But can we take the square root of negative numbers? Not while staying in the reals, right? This would give us an imaginary number. We're not dealing with imaginary numbers. So this gives us a problem. We have getting an undefined issue. Now if n is even and b is greater than or equal to 0, then very simply b to the 1 over n is equal to the nth root of b. And we say that this is our principal root. Okay? If n is odd, we only get one root. It doesn't matter if it's the cube root of 8, that gives me 2. And fun fact, the cube root of negative 8 is negative 2. Because negative 2 times negative 2 is 4, times negative 2 is negative 8. So unlike, say, the square root of 4, which could be 2 or negative 2, right? If you have to remember back when we solved, if you solved these equations in the past, you had plus or minus 2. If you've never done that before, we'll do that in this class. And so the principal root is always the positive root. So in other words, if we have the square root of 4, the principal root of that is simply 2. Okay? Well, both 2 and negative 2 will multiply by themselves twice to give us 4, right? In other words, both 2 and negative 2, when multiplied by themselves, will give us back 4. Okay? This is our principal root. And so that's kind of the breakdown here. Okay? So anytime we're dealing with, especially in a generic sense, if I say b to the 1 over n or anything like that, we can assume that either n is odd or n is even and b is greater than or equal to 0. We're going to assume that we're not in this undefined case because then we're just undefined and everything breaks down. Then we don't have to worry about it. But either way, if n is odd or n is even and b is greater than or equal to 0, it is defined to be the nth root of b. Now, that's great, but that doesn't encompass all rational functions. That only encompassed rational functions where the numerator was 1. So what if the numerator is something else? Let's look at that. And we're going to do it twice because we can get two different things depending on what we do first. Okay? So we can have b to the m over n. We have b to the m over n. Now, to remind you guys on fractions, right? If I have the fraction m over n, I can rewrite this as the product of m times 1 over n. Because when we multiply fractions, we just multiply straight across. So we think of this m as m over 1. We multiply the m times 1, the 1 times n, we get m over n. Now remember, multiplication can go either way, right? So it could be written as m times 1 over n, or equivalently 1 over n times m. And that's the difference that's going to give us these two situations here. So what I want to do is I want to look, okay, so if I break this up, so I have b to the m times 1 over n, and here we're going to do it the other way around, like this. Now the rule that we're going to use here is a rule from yesterday that said if I have b to the m to the n, that was equal to b to the m times n. So if we have something raised to a power, we multiply those exponents together to combine them. But remember, this is an equal sign, which means I can go both ways, which means I can take the product in an exponent and split it into two exponents. And that's what I'm going to do here. So following this rule, this situation here gives me b to the m to the 1 over n. And down here, this gives me b to the 1 over n to the m. Now, what I want to apply here is I want to apply this rational exponent rule that we just talked about. And that simply, now here is really easy because we can just focus with inside the parentheses, and it says b to the 1 over n is, again, assuming we're not in the undefined case, that here we get the nth root of b, and that is all raised to the m power. Now here, inside the parentheses I have b to the m. I can't do anything with that. That's as simple as it gets, right? We're not going to use the definition that b times b times m times. That doesn't help us. But what I can do is I can treat this whole thing as the base, and it's raised to the 1 over n, which means this is b to the m the nth root of b to the n. And so these two things are equivalent just using these rules. And so what's really cool about that is we can do things like, let's say 32 to the 3/5 power. Now you can absolutely do this on your calculator. We'll talk about exactly how to type that in just a sec. But let's do it by hand. Let's look at these two situations. So what I'm going to do is I'm going to write this twice using both of those two formats. 32 to 3/5. So using this first format, okay, notice the denominator is the root. So in this case, I would have the 5th root of 32, and the numerator is my exponent. So 32 to the 3rd. Down here, I would have the 5th root of 32, and then that's raised to the 3rd. Okay, so I want you to think about that. Which one's easier? One sec. So, if we grab our calculators, because these are going to be big numbers, so we grab our calculator, and I just want to evaluate the first thing on each of these. So, what is 32 to the 3rd power? Well, 32 to the 3rd power gives us 32,768. I don't know what the 5th root of that is. I have no idea even where to begin. But let's assume that I'm a nice teacher, because I am, and I gave you a problem that you could do without getting too crazy. So what's the 5th root of 32? So I need to find a number. When multiplied by itself 5 times gives me 32. Well, 1 is always 1. 3 times 3 is 9, times 3 is 27, times 3 is 81. That's way too big already. So the only number it could possibly be is 2. Let's double check. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that means the 5th root of 32 is 2. So that means this becomes 2 to the 3rd power. 2 to the 3rd power is just 8. Which means the 5th root of 32,768 is also just 8, because these two things are equivalent. So you can see this one's a little easier to work with, especially if you're doing mentally, whereas this one here gets big numbers and stuff like that. So when you're trying to work through problems, you may decide to go one way or the other, depending on what things you know, what things you're able to deal with. Now, how can I type this into my calculator all at once and just have it give me an answer? Well, the answer to that really depends on what type of calculator you have. So I'm going to show you my calculator. So this is a TI-84 Plus. Depending on what year you bought your calculator in, if it's an 84 and what version it is, you're going to have different things. If you're an 83, you're definitely in the other category than this one, and I'll show you that in just a sec too. So in this calculator, so if I hit 32, and then no matter what, in both calculators, we're going to hit 32, and then we're going to hit this button here, which does exponents. Bam. Now my calculator, it gives me this lovely little box up here, and I can really just easily go, okay, that's going to be to the 3/5. And then I hit enter, and I get 8. Okay? But what if my calculator doesn't give me that? Don't worry, it's really easy. Okay? You're going to type 32, and then it's going to give you this little icon. And what your screen should look like is, it should look just like this. So once you hit that button, this button here, it's just going to put this up on your screen. And now this is where it's really critically important for you. You have to use a parenthesis. And then do 3/5 and close your parenthesis. This right here, your calculator will interpret this as 32 to the 3/5. If you don't put that parenthesis on there, so you do this, your calculator is going to interpret this as 32 to the 3rd divided by 5. So you have to make sure you use these parentheses. This is the appropriate way. Okay? Now if you have a calculator like mine and you use parentheses, it's not going to hurt anything. It's not going to make any issues. Okay? So, make sure you guys are very careful with what you're doing. I'm working through that very simply. That's it for rational functions. There's really no more to it. Rational exponents, not rational functions. What you're going to be doing with this is just combining things just like normal and maybe applying a few problems like this. Okay? When you're combining these using those exponent properties that we talked about, it all still works the exact same. So let's do one example like that. And I'm going to do a very, very simple example because last video we did a few examples. So this example could be something as simple as, let's say we have 3x squared y to the third times 4x to the 1/2. Okay, that's it. So let's simplify this. Remember, to simplify something, we need to get rid of all parentheses. We need to have all of our variables occur as few times as possible, and in this class, it's pretty much always going to be once. We need to have all of our numerical values calculated, and we need to have all positive exponents. So, all of our exponents are positive, we're good. What I need to do first, I can't multiply these together because I have that exponent out there. So I want to distribute that exponent. And when I do that, I get 3x squared y cubed times 4 to the 1/2 power times x to the 1/2 power. Now I just have a string of multiplication, which means I can now just rearrange these into whatever order I want, and I'm going to rearrange them so I have similar terms next to each other. So I get 3 times 4 to the 1/2 times x squared times x to the 1/2 times y cubed. Now we're just going to go through and evaluate and simplify as we can. Before I can multiply the 3 and the 4, right? So that's something that some people will kind of, okay, multiply the 3 and the 4, then we'd apply the exponent. But remember, PEMDAS, parentheses, then exponents, then we do multiplication division. So I need to apply this exponent. So I have to do what's 4 to the 1/2 power? Well, remember, 4 to the 1/2, denominator is 2, so this is just the square root of 4. Now you can absolutely write this, and that's totally fine. You're not going to lose any points. It's nothing, fine. It's just a little extra. You don't need to do it. Okay? So what's the square root of 4? That's 2. So 4 to the 1/2 is 2. And now you could write this down as another step, or I'm going to just kind of make a life simple. So we already did all that work there. I know that that's 2, so 3 times 2 gives me 6. Okay? Now the next says to do x squared times x to the 1/2. The same base, so how do I combine those exponents? That's right, we add them. So I need to add these together, which means I have to add 2 plus 1/2. Now if you remember, to add fractions, you have to have a common denominator. So what I need to do is I think of 2 as 2 over 1, and so I'm going to rewrite that. So the denominator is 2. To do that, I multiply this by 2 over 2. So that gives me 2 times 2 is 4. 2 times 1 is 2. I still have my plus 1/2. So I have 4 halves plus 1/2. Lastly gives me 5 halves. Now, you can do that on your calculator really easily as well. Okay? So I want to show you guys how to do that, just in case it's been a while since you have. So we have 2 plus, and we'll use parentheses, 1/2, and enter. You get this 2.5. Now we want to keep this as fractions because I'm telling you to keep this as fractions. So how do I do that? Well, our calculator does it for us again. So what we're going to do is we're going to use this button here that says math. Notice that first option says arrow fraction, or frac. What that does is it says take whatever's in front of it here, so in this case A and S, which is just simply asking for the previous answer, saying take the previous answer and convert it to a fraction. And we get 5 halves, which is exactly what we have right here. So that was all to combine our x's. So what we end up with is x to the 5 halves. There's only one y there, so that's already simplified, so we have our y cubed. And that's it. That's our problem. We took this, simplified it down to be 6 times x to the 5 halves times y cubed. So I hope you guys understand that. I hope you guys make sense to you. Follow these rules. If you're concerned about doing the math with the fractions, you have your calculator. Know and learn how to use it, and it will save you. But it's always a good idea to know how to do these on your own anyway. All right, you guys. That's the end of this lecture. I'll see you guys next time.